Hi there, my name is Sean Andrew O'Manning, and this is my virtual reality technology presentation. Virtual reality is an interactive computer-generated experience taking place within a simulated environment. It incorporates mainly auditory and visual feedback, but may also allow other types of sensory feedback. This immersive environment can be similar to the real world or fantasized. As part of this assignment and blog research, the area in which I focused on was within manufacturing. Within the last decade or so, virtual reality has become a key element of the manufacturing process as a whole, with top companies the world over increasingly utilizing the technology. Computer-aided drawing is without doubt one of the greatest things to ever happen to manufacturing since automation. CAD has allowed engineers and designers alike to prototype and design to the nanometer of precision. Since the first CAD systems in the 70s, its evolution carries today with cutting-edge programs at an engineer's disposal. But CAD has also evolved into the VR realm. Companies can now prototype and design products and concepts using CAD within an immersive 3D virtual reality environment. CAD for VR is not yet mainstream as its desktop counterparts. However, top companies and researchers are uncovering and experimenting with its potential. As part of my blog series, I looked at several companies utilizing this technology. A great example I found was on the design of an automobile using virtual reality by Seymour Powell, a multidisciplinary design studio based in London. The studio developed a 3D VR software for modeling the design of a car. The benefit of this application is the ability to get real-time perspective of the car whilst drawing and editing the model. Another great benefit of this application is the ability for multiple collaborations to join in on the modeling process, whilst in the virtual space. In a demonstration video, the studio gave a great insight into how beneficial the use of VR for manufacturing can be in terms of CAD. Designers can visualize in a true 3D perspective and get a better understanding of 3D spacing for real life, and a perspective on a one-to-one scale, something that is not really possible with 2D CAD. A more popular user of this type of technology would be Ford. Ford's Design Labs lets designers and engineers, and also researchers, to experience a concept before an actual prototype is created. This enables early evaluations and analysis on materials, colors, and craftsmanship, as well as aesthetics, packaging, safety, and ergonomics. Teams across the globe in Ford centers can see the live feed and also make instant feedback. This demonstrates a truly collaborative process on a worldwide scale, and with the worldwide market in mind overall, the use of this technology has improved production timing and reduced costings, making understandable why the use of 5 has doubled every year since 2013. Following on from that, Ford is also working with VR for the design, visualization, animations, and rendering of their vehicles and prototypes before they make it into product. The team known as 2000X is at the forefront of this development for Ford, headed by design manager Jerry Kearns. As users are immersed within the virtual environment, they are able to draw and visualize their design ideas. Another company using this innovative technology is Alstom, the global transportation giant, responsible for many railways and urban metro system technologies. Alstom is currently working with VR in a similar fashion as with Ford, as using it in a more intuitive CAD tool for design as well as ergonomic testing, quality testing, and training. What's interesting about Alstom's approach is that not only are they using the head-mount display of a VR system to navigate an environment, but also a practically built set to mimic the environment of a train interior, once again adding a layer of depth to the experience. VR for manufacturing not only falls into the design and prototype element, but heavily the training, simulations, setup, and assembly. From my research, I found out just how beneficial the technology is as a whole to the manufacturing process. A great study by the University of Utara in Malaysia gave great insight to the benefits of the use of VR for manufacturing. For training, for example, in the manufacturing environment can often be dangerous, expensive, and in some ways impossible in actual reality. And now VR can help tackle these issues in the fact the virtual experience gives the user a more flexible and open method of learning. Here's a quote from one of the key researchers. VR-based manufacturing training duplicates an entire continuous manufacturing process, giving each trainee their own factory to learn in. The same idea also goes for assembly, with the idea that VR space gives the designer a further and expansive immersive CAD system that has the potential to completely expand how mechanically designed parts are assembled and evaluated. Also, the setup of a manufacturing factory environment can often be physically exerting and complex setup. With VR, users have the potential to immerse themselves in a proposed 3D model plan of the factory, office, or warehouse, which in turn has the potential to reduce planning, time, cost, productivity, and assembly setup. In terms of statistics and analysis of VR in manufacturing, Centric Digital gathered some amazing stats on info in relation to this. 39% of large companies use VR to train employees in simulated environments. 41% use VR to enhance communication between employees, and only 11% aren't using VR. Also, 73% of millennials expressed interest in implementing VR into the workplace, as well as the previous generation, the baby boomers, with a 70% approval rating. From all I've gathered, VR is indeed the future for design, training, simulation for manufacturing. With top companies like Ford and Alstom utilizing the technology as standard practice, and more companies jumping on board, it's fair to say the technology for now will continue to innovate the domain of manufacturing. In my opinion, in the next 10 to 15 years from now, I would say that VR within manufacturing will become more of standard practice, in particularly immersion, simulation, and design prototyping, as from what I've seen and heard, makes for a more insightful, intuitive, and impactful experience as a whole. From that, VR for manufacturing is a fantastic yet exciting technology. As we go into the next decade, it will be very interesting to see where it goes.